Earlier, we took a look at properties of integrals, so I'm going to go through this first example, really breaking it down based upon the properties. But after that, the second example, we're just going to kind of skip all those properties, take them for granted, and just, basically evaluate the integral the way you probably should do it. But when things get a little more difficult, it doesn't hurt to break it down to these properties. So let me show you. The first one was that sum and difference property, and that's the first one I'm going to use. Which just states that if we're separating anything by plus or minus sign inside the integral, we can just break it down to individual integrals. So I'm going to integrate each of these, or find the antiderivative of each of these individually. We also had that constant multiple rule, so that 6 that's in the front can get factored out to the front there. So we can really just focus in on that x squared. Same thing with negative 5. Same thing with that 3. So let's focus in on evaluating each of these integrals. So this first integral here becomes x cubed over 3. But don't forget, we do have that 6 being multiplied. This second integral here becomes x squared over 2. And then this last integral here, integral dx, when you integrate nothing like that, like this situation, it's just going to be an x. Think about that. Derivative of x is 1, right? So it just goes away, and so that's what's going on here. You're integrating basically 1, which is just going to be x. Integral dx is just going to give you x. So it's something to remember there. Typically, that's kind of a rule that people forget about, and they get confused by that kind of thing. Don't let those easy things be the things that mess you up with these. And then 6 over 3 is 2. And that's just 5 halves plus 3x. And then don't forget plus c. I'm sure Khan's going to have it automatically there for you, and they do. Usually, it's not too much of an issue. In the AP, it's usually in the multiple choice that you have to do that. In the free response, they usually give you an initial value and have you solve for c. So c is not so much of a big deal. So what happened here? If it helps you to break it down like that, if that made a lot of sense, go for it each time. That helps you keep track. But what I would do personally is I can see that I'm adding an exponent to that. So it's negative 3x to the 5th over 5. This one is adding an exponent, adding 1 to the exponent there, divide by the exponent. Derivative of 8x is 8, so integral of 8 would be 8x, and then plus c, of course, and then just simplify it. So our answer would be negative 3/5 x to the 5th minus 2x cubed plus 8x plus c. So maybe you want to go through a couple of them this way, breaking it down each step. And then once you get the hang of it, then you can go ahead and just start jumping to the end there, essentially. Well, you can kind of see, you can kind of picture that 6 is going to be in the front, and you get this anyway, so you don't really have to separate it out as much. It's up to you. I probably would recommend going through a few of these, because when things get a little more difficult, it does help to know these rules here, these properties here, and use these properties. But derivatives, it might have confused a little more, but honestly with antiderivatives, this actually helps out quite a bit sometimes. But once you get the hang of it, I wouldn't want you spending 5 years on the AP test on a quick and easy question like this because you want to just write out every little step. Sometimes it helps just to kind of jump to the end there and get the hang of it over time. So that's kind of more up to you, I think, on that one, on when you're ready to jump over to doing this.